Welcome to the Explainer. Today, we're diving into a really cool new AI model that's making some serious waves. Why? Because it's making powerful text analysis accessible to pretty much everyone. It's called Tarka, and it's a whole family of compact, super efficient models that really pack a punch.
So let's just kick things off with a big what if. What if we could finally break free from needing super expensive, specialized hardware to run advanced AI? I mean, what if you could run a powerful, multilingual model right on your everyday computer?
To really get why a model like Tarka is so exciting, we first kind of have to take a step back and look at the usual headaches we face with most of the big text AI models out there today.
You know the drill, right? So many of these incredible models need ridiculously powerful GPUs, which, let's be honest, cost a fortune. The models themselves are absolutely massive files. Plus, a lot of them really struggle to understand more than one language well. And when you add it all up, the operational costs just go through the roof.
And this is exactly where Tarka Embedding enters the picture. It feels like it was designed from the ground up to tackle these specific problems, making some really powerful AI a lot more lightweight and way more accessible.
So what is it really? Well, simply put, Tarka is a new series of AI models that are small, smart, and yep, you guessed it, they don't need a supercomputer. They're what we call text embedding models, which is just the technical way of saying they are experts at turning words into numbers so a computer can understand the actual meaning behind the text. And it even comes in two lightweight versions, a 150 million and a 350 million parameter model. Now that might sound like a lot, but trust me, in a world where models have billions of parameters, these are tiny. Each one's built on a slightly different foundation, which just gives you options depending on what you need. It's all about flexibility. And here is a real game changer. It's built-in language skills. Right out of the box, it covers 8 major world languages. We're talking English, Spanish, French, German, Chinese, the whole shebang. This makes it incredibly versatile for just about any global application you can dream up.
Okay, so you're probably asking how in the world does a model this small perform so well across all these languages? Well, the secret sauce, it turns out, is all in its very unique training method.
They use this really clever technique called on-air dynamic sampling. Think of it like this. There's a huge, powerful teacher model. This teacher watches the smaller student model, which is Tarka, and it pinpoints the exact examples that Tarka is struggling with. Then, Tarka gets trained only on those tough examples. It's like a super focused tutoring session for an AI, and it makes the whole process incredibly efficient.
It also uses something called bidirectional attention, and this is absolutely crucial. It means the model isn't just reading a sentence from left to right. It looks at the words that come before a word and the words that come after it to understand its true meaning in the full context. It's the difference between reading a line and understanding the whole story.
Okay, so that all sounds fantastic in theory, right? But does it actually hold up in the real world? Let's put Tarka to the test and watch it perform a semantic search.
So here's the setup. The model was given a simple query to search through a few documents about our solar system. The question, which planet is known as the red planet? I mean, for a human, that's pretty straightforward.
Now the documents it had to search through had a bit of a trick inside. Notice how the text for Mars and Jupiter both mention the word red. This sets up a classic test. Is the AI just going to match keywords and get confused, or does it actually understand the meaning behind the question?
And the results speak for themselves. The model absolutely nailed it. It correctly ranked the Mars document as the #1 result, with a really high similarity score of 0.89. Jupiter, with its great red spot, was a distant second.
And this is the key takeaway right here. The model wasn't just matching keywords. It understood that the phrase reddish hue combined with red planet was semantically way closer to the query than Jupiter having a great red spot. This shows real contextual awareness, not just a simple game of word spotting.
So when you put all of this together, what does it really mean? Let's zoom out and look at the big picture, because this is where you really start to see why a model like Tarka could be a potential game changer.
For me, the most revolutionary thing here is that this level of nuanced, multilingual performance is accessible without any specialized hardware. It doesn't need an expensive, power-hungry GPU to do its magic.
I mean, just look at that, 0%. That's how much GPU memory was needed to run this whole task. It just goes to show how incredibly lightweight and efficient this model really is, doing all of its thinking entirely on the system's CPU.
So, to sum it all up, Tarka delivers on 4 key promises. First, accessibility. It runs on the kind of CPU you probably already have. Second, versatility. You get powerful performance in 8 languages. Third, intelligence. It delivers deep semantic understanding. And fourth, efficiency. We're talking a tiny model size and super low resource usage.
And all of this leaves us with one final big thought. What new applications, what new tools, what new possibilities open up when anyone, anywhere, can run a smart, multilingual AI on their own local machine? The potential is just enormous.